Hi, in this video we're looking at 2018 Leaving Cert Mathematics Ordinary Paper 1. This is question 7. This is an arithmetical sequence, arithmetical series question. So we need to just make sure that we remember two formulas. I'm going to write them down on the top of the page over here. And the first formula is for the nth term. So T of n is, we take the first term a1 plus n minus 1 multiplied by the common difference. And the next formula that we should probably remember for this problem is the sum of n terms, and that is written by n over 2. And in the bracket we have 2 by twice the first term plus n minus 1 by the common difference. So these are two formulas that we should recognize and remember for this problem. Okay, so let's get right into it. What does the problem tell us? So we have part of the seating arrangement as shown. The seats are arranged in rows. Row 1 is nearest the stage, has 28 seats. So from here I'm going to just highlight this because this tells me exactly what my A1, the first term of the arithmetical series, is. Each subsequent row behind that contains one more seat, so from here I can figure out that A1 is 28 and D is equal to 1, which is good. So each subsequent row has one more seat. Row 2 has 29, row 3 has 30, and the first part of the question we have to find the number of seats in row 10. So you can start counting. 1 is 28, 2 29, 3 30, 4 31, 5 32, 6 33, 7 34, 8 35, 9 36, and 10 37. Or you could say that T10 equals to 28 plus 10 minus 1 multiplied by 1, which is obviously the same, 37. We're also told that there are 50 seats in the last row. We have to figure out how many rows of seats are there in the theater. So now I know that 50 is equal to 28 by add n minus 1 times 1. Solve this simple equation. So 50 equals to 28 plus n plus n minus 1, and from here I get that 50 equals to 27 plus n, and that tells me that n has to be equal to 23. Straightforward enough. Using the formula for the nth term in a sequence, then we can find out the total number of seats in the theater by using the sum of arithmetical series. So sum of 23 terms will be written as 23 over 2, and in the bracket twice by 28 plus in the bracket 23 minus 1 multiplied by 1, close the bracket. And we can throw this expression into the calculator to get the value of the total number of seats equal to 897 seats. So that's that. Continuing along the same problem, we're told that on a particular night 600 people are at a show in the theater. Now we're assuming that people are seated only in rows closest to the stage. They have filled the first n rows and there are some people seated in the next row. So we have to find the value of n and find the number of people seated in the next row. Okay, so in order to do that we're going to have to solve a small quadratic equation because we're using the formula for the sum of n numbers or some n terms in the arithmetical series. We write n over 2 by simplifying what's in the bracket from the expression above twice by 28 is 56. It's exactly the same expression, so 56 plus n minus 1, and we know that this is equal to 600. So now I can multiply the brackets out. So let's see, simplify first, multiply both sides by 2. So n 55 plus n equals to 1200. So n squared plus 55n and minus 1200 equals to 0. And now by using the minus b formula, I can solve this equation. So in this equation, a equals to 1, b equals to 55, and c equals to minus 1200. So putting this into minus b, plus or minus b squared minus 4ac, all that over 2a, I get that n is equal to 16.7, which is the positive solution. Negative solutions don't work in this particular case. So the positive solution is 16.7. And if 16.7 is the number we're looking for, so we have to figure out how many people are seated in 16th and in 17th row. So by looking at S of 16, we just need to put 16 over 2 by 56 plus 15, and that is equal to 568. So 568 people are seated in 16 rows, so that's 16. Number of people in the next row is 600 minus 568, and that equals to 32. So 32 people will be seated in the next row. Going to the next part of this question, we're told that for a particular show, adult tickets cost 25 each and children tickets cost 12. Find the total income from ticket sales if 276 adult tickets and 212 children tickets were sold. So that's simple arithmetic question by putting 276 multiplied by 25, which is the adult tickets, and we add 212 by children ticket price 12. We get that this value is equal to 6,900 plus 2544, which ends up being 9,444. And then moving on, for different shows, 752 tickets were sold. The ratio of adult tickets sold to children tickets sold is 3:1. We have to find out how many adult tickets and how many children tickets were sold for that show. So we know that 752 tickets were sold, and that we have to divide 752 into 4 parts, because 3 plus 1, that's 4 parts. So 752 divided by 4 equals to 188, and that's the number of children tickets sold. If 180 is the number of children's tickets, then 752 minus 188 equals to 564. This is adult tickets. And we can add this into my answer sheet, 564 and 188. And then for that show, an adult ticket costs 2.5 times as much as children tickets. The income was 17,578. Find the cost of children's tickets. So let's say that my X equals to cost of child ticket and then 2.5x adult ticket. So by combining the numbers that I calculated in the previous problem with this expression, I can put together a little algebraic equation which says that 564 multiplied by 2.5x plus 188 multiplied by x leaves me with 17,578. And now I can continue simplifying. So multiplying 564 by 2.5 leaves me with 1410x plus 188x equals to 17,578. And I can simplify by adding the left hand side to get 1598x equals to 17,578, dividing both sides by the coefficient of unknown, 1598, I get that 11 equals to x. And that's the price of a child's ticket. That brings this problem to completion, and that's a good place to stop.